Okay, 8th grade, I'm going back over square roots because there's still some confusion about them. And we do need to know this because when we do go back to school, hopefully soon, we will be starting Pythagorean theorem, and that sounds scarier than it is, but you need to know square roots in order to do that. So let's go back to the basics. What is a square root? Okay, well, what's a square? A square is these different shapes. They're shapes that have the same equal sides, 4 sides that are equal and have a right angle in the corner. And I find the area of a square by multiplying those sides together. So 1 times, let's get a different color going here. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6 is 36. That's how I find the area of the square. So if I was to go through and count each and every one of these little squares inside of here, I would get 25. The square root is kind of the backwards of finding the area. So it's when you're given the area, well, how do you know what the side is? Okay, so for a perfect square, it's not too incredibly hard to figure out because I know, oh, what 2 numbers can I multiply together that are the same that will give me 25? Well, I know 5 times 5 equals 25. So the square root of 25 is 5. Think of each of these sides as the roots. When I am talking about a square root, I use a sign called a radical sign. So instead of saying, 5 is the square root of 25, I would say 25 underneath this radical sign, and I can either say it as radical 25 or the square root of 25, is 5. Now, I was using some perfect squares, but most square roots are irrational. An irrational number is a number that cannot, first of all, it can't be written as a fraction. So no 2 numbers that you can divide are going to be irrational. Because if I can write it as a fraction, I can divide it. An irrational number has decimals that never end, or are sometimes called non-terminating, and they never repeat. And so, for example, let's take a look at, let's just pick any random number that is not a perfect square. The square root of 24. That goes on and on and on, and it only stops because my calculator runs out of room, okay? Because they go on and on and on and on forever, we can't actually say a specific value for them. We can only estimate the value. So in 7th grade, we learned about a special number, the first irrational number that we learned about, pi. And we say pi is equal to 3.14, or a more accurate way of saying it is that pi is, and these little squiggly lines mean, approximately equal to 3.14. It's not really 3.14. Because pi never actually ends and it never actually repeats. So, for example, I've got the first several digits here, but I ran out of room, so I couldn't keep going. And if you are bored, you can look up the first million digits of pi, and people have calculated out to the millionth digit of pi. And never, ever, ever is there a pattern or a repeat that we see. So this is different than the numbers that we learned about in 6th and 7th grade. For example, if I have, say I have 1 and I divide it by 3 and I end up with 0.33333333, right? And we say repeating, okay? And then we said a better way of writing that would be 1 over 3 is equal to 0.3 with a repeat bar. But when we have an irrational number, there's never a pattern that comes up. So when we have an irrational number, we tend to put just the ... at the end. We don't use the repeat bar because it never repeats. So because I can't actually say the exact value of a square root, I'm only going to get some sort of decimal that's really, really long. When I'm asked to estimate a square root, sometimes I have to say, well, it's in between this and that. So say, let's go back to the square root of 24, okay? Now, I know that the square root, if I look back here at my page that I just turned over, the square root of 16 is 4, and the square root of 25 is 5. So any number that's under a radical sign that's in between 16 and 24 is going to be, or 16 and 25 is going to be between 4 and 5. So the square root of 24, because it's closer to 25, I could say, if I didn't have a calculator with me, I could estimate as being between 4 and 5, closer to 5, right? Because 25 or 24 is definitely closer to 25 than it is to 16, okay? So let's do a little experiment here. So let's do the square root of 16, the square root of 17, the square root of 18, the square root of 19, the square root of 20, the square root of 21, square root of 22, square root of 23, square root of 24, the square root of 25. Well, I already know that the square root of 16 is 4 because that's a perfect square. 4 times 4 is 16. And the square root of 25 is 5 because 5 times 5 is 25. All these are going to give me an answer that's somewhere in between 4 and 5. And depending on if it's closer to 4 or closer to 5, I would put it closer to that on the number line. So let's try to put the square root of 19 on the number line, okay? Now, I know that it's going to be in between, so let's do this. 4, 5, 6. The square root of 19 is going to be in between 4 and 5. And it's going to be pretty close to the middle, but a little bit closer to 4 than it is to 5. So I'm going to estimate its place on the number line as being about right there. The other way to do this, because you guys are allowed to use calculators, is to just find what is the square root. Well, let's see. Square root of 19 is 4.358, and then dot, dot, dot to show that it keeps repeating. Let's do all of those just to see how much closer it gets to 5. So let's see. Square root of 17 is approximately equal to 4.123, dot, dot, dot. The square root of 18 is approximately equal to 4.242, dot, dot, dot. I already did 19. The square root of 20 is equal to, or approximately equal to, 4.472, dot, dot, dot. Square root of 21. Do you see how I'm getting closer and closer to 5? 4.582, dot, dot, dot. Square root of 22. 4.690, dot, dot, dot. 23 is approximately equal to 4.795, dot, dot, dot. And the square root of 24, which we already talked about, is approximately equal to 4.898, dot, dot, dot. So as my number under the radical gets closer to 25, the number that it's equal to is going to get closer to 5. So let's do one more. So say I also had on here, estimate the location on the number line for the square root of, let's go with 11. Okay. Now if I think back to my perfect squares, let's see. 1, 4, 9, 16, 25. 11's going to be in between these two. It's in between 9 and 16. And 11 is definitely closer to 9 than it is to 16. So the square root of 11 is going to be closer to the square root of 9, which is 3. So I could estimate that as being maybe right there. And it's not perfect, it's just an estimate. the other thing I could do is I could just use my calculator, and I can say the square root of 11 is equal to 3.316 ... Okay, so that's definitely, I'm looking at the whole number here is 3, so it's going to be bigger than 3. And then this is, I kind of always think 3.5 is exactly halfway in the middle. So that would be 3.5. And then I just kind of estimate, well, so that's about 3.316, blah, blah, blah.